problem I'm doing, Subhan? What
Uh,
uh
yeah,
what problem do you plan to do, Subhan? I can get started now, that's fine.
you can
Are you
get
ready to
started.
go, or you want Taha to
No,
start?
I'm loading the tab. It's like really slow on my laptop right now.
Okay, Subhan, if you're loading the tab, do you want to go?
Yeah, I can go. Just give me 2 more minutes.
Okay, if it's 2 minutes, I can start with the problem and
Yeah,
we
sure.
can
You can
go
start.
from there. Um, Let me share my screen and maybe you guys can this is one where I'm pretty sure I'm getting it right, but for some reason I'm actually let me you know what, let me do the first one. Just now I have to load a different problem. 1 second, sorry. Let me share this. Hmm. Okay. My screen share should be loading. Let me know when you guys see it.
Yeah, we can see it.
Okay, so this problem, it's a bit different from the other ones because this one you're basically designing a data structure
Oh,
instead of necessarily implementing a data structure. So the problem is called min stack. It's a medium problem. The question asks that you design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So they give you a class min stack with a bunch of different functions that you have to basically complete. And they say that min stack, this function initializes the stack object. Push function takes in an integer, which is a value, and it pushes this element onto the stack. Actually, this push and pop, I mean, there's not many people here, so I'm assuming we don't need to go over it, right? Everyone knows what
yeah.
it is.
Yeah, I think probably everyone here knows about this.
Okay. So this pushes the value onto the stack. Pop removes the element from the top of the stack. Top returns an integer. It gets the top element of the stack. And get min retrieves the minimum element of the stack. All of these functions have to be O of one time. So what I noticed with this problem is that there, this is the most Python magic-y problem
Oh,
I've
okay.
encountered. I looked at the C++ solution and that was a very like I was able to understand most of it, but it's a completely different beast to be honest. So if someone else wants to go over that after, I would I would definitely like if this problem was asked in an interview, I don't think this solution would fly, honestly. But I don't know.
So, I
Um
mean, the real goal is to understand the concept, right? I don't think they want you to, because there's lots of pointer stuff being used there. So that's why maybe you think that C++ is complicated. But I mean, the main thing to keep in mind for this data structure is it's a LIFO. I mean, last in, first out, right?
yes.
So, I mean, whatever the last item you put, you will pop that for the first one. So that's
Yeah.
the whole, I think, only magic that needs to know. But I certainly agree that I mean, unless they want to hire you for C++ programming, they want to make sure is that you understand the concept, right? And
Yeah.
be able to
Uh,
implement.
and to be fair with this problem, they're like luckily they're not making you even do all the functions, right? Like they're not making you do a search function or a size function, for example.
Mhm.
They're just doing the very basic ones. The since it's a min stack, there is an extra part where you retrieve the minimum element. So along with all of these functions, we need a way to keep track of the minimum element, and there's a couple of ways to do it. The way I saw in most solutions is that you have basically two stacks. One of them is like the regular stack, and the other one is the minimum stack. And the minimum stack, what happens is um you only push a value if it's lower than the top of this stack. So basically every time you push something to the minimum stack, it's basically whenever you find a new minimum.
Oh,
And the advantage of this is that when you want to get min, you can just return the top of the stack because you know the top of the stack is the lowest or the minimum value. So that's one way to do it. I did see another solution and it made more sense to me where you just have some value, some integer value that you update in one of these functions. I believe it was the push one, but most solutions suggested have two stacks. So that's what we'll be doing here. So for initialization, we can initialize those two stacks like this. We use self because of how the class is constructed. Like in all these LeetCode problems, whenever you want to call, whenever you make multiple functions, you have to use the self parameter. And then you put self in front of the function. But this first stack is our regular stack. The way you initialize a stack is like this. It will be the same in the other problems. It will be the square brackets in Python, and you can already just push and pop to the stack. Like it acts as a regular stack in Python. But this is one stack. We will also have a second stack. So I heard in the like someone the guy who runs LeetCode, he described this as close to like an array list in Java, or like he said it was not a regular array. So that's where kind of the Python magic comes in, I think, because this gives you a lot more functionality right off the bat than a regular array. It's much closer to a stack. So we have two stacks, we initialize them. Push is the main function. We're given a value. So if we want to push it to this stack, we just have to append it. Append is basically pushing. You're just adding it like to the end of a list or to the top of a stack. They're considered the same thing. So we can just append the value. And then now what we need to do is talk about the min stack. So for the min stack, we said push a value if it's lower than the top of the stack. So first we need to check if the min stack is empty. If it's not empty, then we need to check, like we need to compare value with whatever is at the top of the minimum stack, and then we may need to update value. So the way we do that is we say val equals minimum of two things, of itself and the top of the minimum stack. So what this is saying is you take value and you update it. If the min stack is not empty, then you check what's in the min stack, you compare it with value, and you update value accordingly. So you may have to update value to be the minimum value. And actually, it might be better to name it this, min val, where min val is the minimum of value and whatever's in the minimum stack. Now, with this min value, we can basically
can you explain what is -1 in the min stack?
-1 means so -1 equals top of stack.
Top of the stack. Okay.
Yeah. So this is like the last position, whereas 0 would be bottom of the stack. Yeah. So in Python, you will generally see this convention. Same in the other problems, because usually you have to look at the top of the stack. That's what you care about, since it's last in first out. You generally don't really care about the bottom of a stack. Usually you have to like recurse down to that point or just keep popping off the stack until you reach this point. But between these two, you usually care about this -1 index. So we're updating.
Here you will have, I mean, like you said, you have a luxury of using array, and you have in Python you have access to the -1, which is the first one. But if you're using linked list, then this implementation may be a little bit more complicated, because then you will have to parse it to get there.
Yeah. And actually that would be interesting to do, because I've never done it with the linked list.
Okay.
Yeah. But so this just updates the minimum value. This minimum value we can now push onto our this should be self.stack.
Yeah.
Because we're just pushing onto our normal stack, and then self.min stack. We can append this minimum value. So we are preserving the idea that we only push new minimum values to the stack. Otherwise, minimum value will just be value. So no change. Now, for pop, there's a built-in pop function. You can just do stack.pop. So we will just do that.
Also, append's opposite function is pop. Okay.
Yeah. So this will get the top element from the stack and remove it from that stack. Yeah.
So why we are popping from the min stack also?
Because okay, yeah, actually this is I was gonna ask about this as well because I know we have to pop both, but the thing is like the min stack and the stack could have different values, right?
Yeah.
Because the min stack just holds the minimum and the top of the min stack might not be the top of this stack. So originally like I was a bit confused as to I thought we needed to do some extra checks. Like what happens if you pop both of these stacks and then afterwards this minimum stack no longer accurately reflects the minimum of this?
Yeah.
What do you do in that case? Yeah, actually, I don't know if anyone else wants to answer that because I'm not sure why. Like, I feel it
I
should
just realized
be.
I have that same thing too in my code. I don't really, what happens if you just remove it? Will it?
Well, we can't remove it, right? Because we do have to pop from both. There are cases where like we remove the minimum element from here, then we have to remove the minimum element from here. Maybe it's due to the order where like when you push stuff, like when you push, you are always pushing, like you are accounting
Yeah.
for the minimum value in the minimum stack. So that way when you pop from both, it works out. We can't remove it. Like if we remove it, we know it will no longer be accurate, right?
Yeah, you're right that every time there is a push command, the item will get pushed. But then the question is that the pop should remove because the pop will from the min stock, the pop will remove the smallest item. And that item may be somewhere else in the stack or how?
Yeah, that's what, it might be like a second element in the stack, but in the min stack, it's gonna be the top element because it's the most minimum.
So I'm just trying to envision two stacks right now. This will be the regular one, this
Yeah.
will be the minimum one. And when I push four, four will get pushed onto minimum. Three will get pushed onto minimum. Five, I think three, what happens when I push five? So we check if the min stack is empty or if the min stack like it's not empty. It's not
Oh,
empty.
yeah. So it will push the
So
three again because
yeah, we have to push
five.
three again.
Yeah. So that's why.
Yeah, so I think in this scenario, like when you pop from here, forget the -1.
Yeah. Yeah. Yeah.
You pop
Okay.
five, you pop three, then this seems to work.
Yeah. 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 Makes sense now.
Yeah. Yeah, I'm not sure if I would like understand that in an
No, I
interview.
think you got it right. So Subhan, you also understand, right?
Wait, so you're saying that, can you
So
repeat that?
look at the condition on line number 11. So when we are pushing the min value, we are only pushing the smallest of the two, right?
Yeah.
So look at his example where was your original list?
So in the min stack, we're always gonna have only one value.
No, not necessarily.
No. So in the min stack, like Subhan, if you look at this, right now my min stack has like my min stack and stack, they always have the same number of values because you're always like pushing and popping from both of them at the same time. So they will never have a different number of values. But what can happen is, let's say you push a number that's not the minimum. Like let's say the minimum is three and now we push five. What's actually going to happen is in the min stack, three will automatically be pushed
Because
because this is checking like if this value is not a minimum, you're just going to push again whatever is on the min stack. So three will get pushed again, even though five was just pushed.
Yeah.
So when you pop it, then three is still the minimum of this stack. So it somehow works.
yeah, yeah. No, I think it makes sense now.
Oh, okay.
Yeah. So it's this idea of duplicates where 433 this is what allows for this type of structure. So this is why like I would have I would probably in an interview I would probably look at doing just like have some value like int min and I would just keep track of this in the different functions. But a lot of solutions suggested 2 stacks, so that's what I thought I would go over. For top, we're gonna use this -1. So we can, when you return the top of the stack, you're returning the -1 index. So we can just return we don't you don't really care about the, like, you're not popping anything, you're not changing the stack here, so we don't have to do anything to the minimum stack. So we can just return the -1 index.
Oh, why
And then,
-1? The top should be the top of the stack should be the top element, not the first element.
yes, but first element is
Oh,
0.
so you
Yeah.
could actually call return. Oh, our top function does not return anything. Okay, okay, that's fine. Because normally top item returns the value of normal implementations. I'm not saying here. Normal implementation returns the value of when you call the top function, it returns the value of the top element. But in our implementation, it isn't. So then, yeah, it works.
Well, it should still return, like when you say this should still return the top element, right?
Yeah,
Top
no.
of the stack.
So, but look at our top function. Where is the top function?
Here.
Yeah. No, so we're yeah, no, I was talking about the pop function. I'm sorry.
Oh, okay.
Yeah. So the pop function normally return that, but yeah. So I meant the pop, but that's fine.
Okay, yeah. Yeah.
Okay, okay. I think this is good.
So along that line, get min is just basically saying get the top of the min stack, because the top of the min stack is always the latest minimum value or the most minimum value. So we can just return the min stack
-1.
top -1 to get, basically it's basically getting this position where 3 is the minimum. Because this number will always be the minimum. Like going back to this example.
Yep.
This is the number we would be returning for this. So let's run it. Min val. Okay, I think yeah, I think this is why the solution used val, because it had an issue with variable initialization. I'm sure if I like initialize min val like up here somewhere, that would be fine. Maybe if I initialized it with -infinity, that would work, but solutions used like they use the same number val.
Right.
So because you push val to this stack, so
Yeah.
afterwards you can change it and you don't care
Yeah.
like what it's called or anything. So you can just change it to be the minimum of itself and the minimum stack, and then you push it to the minimum stack. So this should work. Yeah.
Okay, cool.
Any questions? If you guys want to see the like just the C++ solution is very I mean it's like my classes were in C++, and even then this is not a fun problem for me personally. But it's like fairly, like it's fairly tame. Like this is still like it's just different syntax. Like your class has public and private properties. Blank constructor. You can still call push on this. Actually, which I don't really know what's happening here, because you have a push function, but then you call push.
Yeah, because that's on the stack.
Yeah,
You are doing self.stack.push. It's the same thing.
yeah. So that function is basically already there, so you can basically make use of that.
Yeah.
Yeah. But I guess
Yeah,
I
but
will.
if you start writing actual code, like you said, the push is already there. But if you're writing it in C, basically, then it makes things much more difficult. You allocate the memory with malloc, and then you basically add it and or keep track of your pointers and delete them when you don't need them. All those challenges are gone, I think.
Yeah, this is very different. Yeah, this is using pointers.
Yeah, so you implement the node first, and then I think this is using proper linked list also. So which is
Yeah, I think this is like the hard version of that problem. This is no longer a medium. I don't think it's fair to call this a medium.
I mean, this is what we have been doing. We had
Yeah.
yeah.
Yeah. I mean, I took a class in assembly. That was my worst class. just because the lower level you go, the worse it gets. But yeah.
Okay,
Would
so Subhanu, wanna do next one or
Yeah.
okay?
a quick question, would implementing this and using a linked list be harder?
No,
would-
not in Python, Rafe, but in C++ or C, you basically will implement the node first, and then you will basically reference that node and create a link.
Yeah, because I mean, like, I feel like implementing a stack using a linked list would be easier because you have one reference to the head, and I mean,
Yeah.
a stack, you only need a reference to the head, right?
Yeah. So
Yeah.
as the min stack would be challenging, but what you are saying, the regular stack will be much better performing in C++ for sure.
I see. Min stack, I mean, min stack, you just, I guess you could just have like in the node, just
Yeah.
have two values, data and min value instead of
Then you are keeping that value along with all your nodes for your
yeah. So you just have one additional
Yeah.
value.
Yeah.
Yeah.
You could do that basically.
Yeah.
All right. Let's go to the next question. Oh, this is valid parentheses. It says, given a string S containing just these characters, which are like the opening brackets and the closing brackets, and determine if the input string is valid. And the way we check if it's valid is, for example, if they like are able to close correctly. Like, for example, this is right because this one, or you see this one happens before this one begins, right? Because, for example, in something like this, we can't have open parentheses and an ending bracket because we first need to have a closing parentheses if we have an opening parentheses.
So let me just give a brief overview. So not overview, but anytime you guys have this kind of a problem, someone will not tell you that will solve with the stack. So wherever you need, a list of things which have starting and then again will be ending brackets also, you will always have to use the stack. And most of these compilers, they are implementing all these statements through the stack because they keep pushing those statements on like all these function calls, they are push on the stack first. So all your calls are put on the stack, and then as you execute, you keep popping them and returning the value from there.
I think even like clicking these tabs, like if I were to click this tab and then I were to close out of it, it would take me back to this tab, right? Because that's also like the way stack is implemented.
Yeah. So keep an eye in mind that if you get a question like this one is saying, oh, I have these parentheses, and make sure that all the parentheses are closing properly, and there could be right now they give you very simple examples, but in the code you have so many of those, especially in the complicated functions where so many ifs and fors and all those things are there. This becomes much more complicated in the longer functions. So those are dealt with using the stack.
Yeah. So for example, if we go to an example test case, something like if we were to have like this, and then something like this, and then this would fail, right? Because we first evaluate this, we would check if it's in the stack, or yeah, we would check if this is in the stack. If it isn't, then what we would do is we return false, right? So the way we implement this is, let's go through this one first. So what we're gonna do first is we're gonna use a hash map, right? A hash map or some type of list to check if the ending character or if the opening character exists in the opening character exists in the stack. If it doesn't, we're gonna append this to our stack. We're gonna always append the opening ones first, right? And then we're gonna keep iterating through our string. We're gonna keep adding the so let me give a simpler example. For example, imagine if we have this works, right? Because our brackets close in the correct areas. So we're first gonna have this one. We're gonna add it to our stack, right? Then we're gonna have this one. We're gonna add it to our stack. Once we reach a closing character, what we have to do is do a couple of checks. First, we have to check that if this is the closing character, that means that the previous one must be its corresponding opening character. So it would have to be this one. So all we would do is we would check if the top of the stack or if stack.pop is equal to this one. If it is, then we continue with the string, and all we do is we just pop this one, and we don't add the closing ones to our stack. We only add our opening ones because we're only checking if the corresponding bracket or parentheses matches the one from the top of our stack. Then now these will be popped, right? And we'll be back here, and now we're on this character. Now our stack only consists of, imagine this is our stack, right? Our stack only has this now in it. Once we get to this character, we then check, does this equal to stack.pop? So we're gonna check if its corresponding character, is its corresponding like bracket equal to this bracket. Since it is, we keep passing on through our list. We return true if our stack is empty, because that means that we were able to parse through the whole string without having any errors. But if there was an open bracket, for example, still left, like for example, if there was an open bracket like this left, we return false, because that means that a bracket wasn't taken care of. So for example, if we have something like this string would return false because we would be able to pop this character over here because there's a opening bracket and a closing bracket correspondence. So we would be able to remove those, but we still have this left and it will be the end of a string and it would return false. So the second question arises is how do we check if they correspond to each other? Like how do we check if this and this correspond to each other? Or how do we check if this and this doesn't correspond to each other? We could use a hash map and map the key of the opening bracket to the key of the closing bracket. So what we're gonna do is we're gonna have a hash map, something like this. And it's gonna consist of all of the opening and closing brackets. So for example, we're gonna have something like, let me use these quotations, something like this. I'll show why we're gonna put the closing bracket as our key and our opening as the value. So what we're gonna do is we're gonna add all of our opening brackets.
So the only reason we are using hash map here is because of we have to find the corresponding.
Yeah.
Okay.
So that's why we're setting, this is the key and this is the value.
Okay.
So we're basically we're just kind of hard coding our hash map here. So, and then the last one would be just the closing ones. So here's our dictionary or hash map that has all the corresponding brackets. We're gonna have our stack over here, and what we're gonna do is we're gonna loop through the string. So let's use a example test case. For example, let's use this one over here. So what we're gonna do first is we're gonna reach this opening character right over here. If we are to reach an opening character like this means that one of these, like over here, these opening brackets is inside of our hash dot values. So all we're gonna say here is if if the character is in hash dot values, we're gonna want to append those to the stack, or append that value to the stack, because we only want to append our opening brackets, not the closing brackets. The closing brackets are used to check from the stack. So we're gonna do stack dot append the character. That's all we do for checking if it's an opening character. Then say we get to this character over here. This is what in our hash map, this is a key. What we're gonna do is say else if s of I is in hash dot keys. What do we do for here? We say we have to pop from our stack and check if the corresponding pop is equal to the corresponding character. So imagine our stack right now is something like, our stack right now is basically just this character, right? And then we get the closing parentheses as our second character. What we do is we have to now check, is that key, or if the current, so our current is this one, right? And you can notice here that's a key. We're gonna check if the key of S of I maps to its value, which should be
But
this.
is this condition, I mean, both conditions look to me the same. Is the first one not in?
What do you mean?
On line number 9, it say if SI is in hash dot values.
So
Pending.
the
Values of
the difference is opening versus closing parentheses.
Oh, okay.
Yeah,
No,
the
but,
key.
no, but still.
What do
So
you mean?
what do you mean? The first character which you are reading from your array, right? You got ST,
Opening,
right?
opening
Yeah.
parentheses.
So you got S. Sorry.
Yeah.
So S is basically your string, and you are reading the characters. You read the first character, and you are
Yeah.
checking if this is in hash dot values. It will not be, so it will go in the else if.
No, it is in the hash dot values.
Oh, it is in hash dot values. Okay, okay, yeah, I was thinking about. I was reading the str. Okay, it is in the hash dot values. Then you basically append it. Else, si is in hash dot keys. Oh, okay. I'm sorry.
Keys is this. Yeah. So then this, for example, is the next character, and this is in the keys.
Okay.
We're gonna say if we're first gonna check one of the basic cases that we check. Imagine if there's nothing in the stack right now, and we just have a closing parentheses, right? We can't just have a closing parenthesis, that doesn't work. We always need the opening parentheses, and the opening parentheses will always be in the stack. So all we can say is if stack is just empty, right? Or that's like the first edge case or the first check. The second check is we're gonna do here is we're gonna say if hash S of I is not equal to stack dot pop or stack something like this.
Okay, that is stack -1. Like earlier, Taha said that this is the top of the stack.
Wait, what?
That's the top of the stack. Stack -1. Yeah?
Or no, 1 second. So what we're checking here is we're saying, imagine our stack is just this and this, right? Or imagine if our string is this was currently in the stack. We're gonna check if it's in the key, which means it's one of these opening parentheses. We have to check if this should be, I think, stack.pop. Because then we're checking, does this equal to this? Oh, is this right? Like,
I'm not sure about the pop, but you're comparing, like you are seeing if the opening parenthesis is in the stack, right? Let me check if I pop or not.
because what we're doing is we have to check from the stack.
Yeah, you are checking from the stack. I don't think I pop, like I don't think you should be popping. I did like, I mean, I'm checking it slightly different than you, but I'm not popping until a certain condition is met, where the like if your open parentheses, if you find the open parentheses, then you pop. Like, do you get what I mean? Like if that condition you're writing, if that is true, then you pop from the stack, but you don't actually pop in the condition. So I
Mm.
think stack -1 should work for yours.
I mean, no, what I'm saying is that I think this does work because all we're doing is we're getting the current character's corresponding value. So for example, sorry, if our current character is this, right? This closing parentheses, right?
Actually, I see what you're doing.
Yeah,
I think pop will work because you're not adding this to the stack, right? You're
yeah.
not adding this to the stack right now. So
Yeah, what we're checking is does this hash as this hash of this character, we're checking its index. So this is the index and it maps this value. So
yes.
this over here is equal to this.
Yeah, those are all opening parentheses.
Yeah. We're checking if this is equal to this. That's correct, right?
Yeah, that
So
that should
yeah,
work.
we're checking if the key corresponds to its value over here.
Yep.
This is our current character. We're checking if that current character's index, its value maps to the stack.pop, since we have to pop it anyway, since we're checking if it's since the top character. So yeah, if
That
it's
makes
not
sense.
equal to stack.top, we're just gonna return false, because that means that one of those either doesn't work. So for example, let's go through an example test case where if it was like this, and this, we would first append the opening brackets. Yeah, we would first append the opening bracket, which is over here, and then we append this one. This one, I put it in the keys. Then I check over here. Does the key's value in the dict or in the hash map, which is this one over here, equal to this one? Since this is the only one that's in a stack, it isn't, so it would return false. So that's kind of the explanation about that. Else, another edge case we would check for is if it's any random character. For example, if it's a number or something from the alphabet, all we would do is return false. So now over here, what can we check? Imagine if our stack still has an extra character left, right? That wasn't checked from the string, and the string we've already iterated through the whole string. That means that we have to check if stack is empty, then we return true. Else we return false, because I was saying again, there might be an edge case where there might be still an opening parentheses left that we haven't accounted for. So yeah, this should work. Let me remove these. I think it should be in hash style values. So it says that, let me see, what did I do wrong? I have all the hashes, the hash maps set correctly. I'm looping through the values. We're appending them to the stack. And we're checking the keys. And yeah, this should be right.
The problem is like your for loop is structured like a bit different than mine, so I can't like
let me do this. Let me say if non-stack. It might be some weird like,
yeah, actually there was a place where like when I'm checking if the top of the stack has the matching opening parentheses, I also check if the stack is not empty. And I don't remember why I had to do that, but
if
yeah.
you check if this works.
But not stack yours.
And now it works, which is weird. I think,
Yeah, I think because not stack, empty stack is an invalid condition, right?
but shouldn't stack equal to this and not stack be the same thing?
I always use not stack.
Yeah, I probably should have used not stack then, because I mean, it's the same thing if you think about it. Like, I'm just checking if the stack is empty, is what I'm checking for.
Yep.
But yeah, this should work now.
I'm also wondering if you can just return not stack. Is not stack a Boolean?
Yeah, it is. So I
Okay.
could. Yeah, that works too. But yeah, I think the main thing of this problem is the reason why I use these closing parentheses first as the keys and then the openings as the values. The reason I did that is because we're only adding these ones to the stack.
Hmm.
We're not adding these
Okay.
ones.
Okay.
Wait, what?
Yeah, makes sense. So basically, you are putting on them on the hash map, the ones which are going to be
We're
possible.
putting them as values. So then when we reach the ones that we need to actually check for, we can easily correspond them to its values because we can't really do it the other way around
Yeah, makes sense.
by looking it up in the hash map.
So the purpose of hash map is only because we wanted the corresponding
Yeah.
bracket. That's really the only. Otherwise, this problem is solved using the stack.
Yeah.
Okay. You guys want to go for another one, or that's good for today?
Well, we can do one more. I mean, we have like,
This was easy problem, took a long time, Saban.
yeah, it's just really, it's the syntax which is
It's
weird.
good to, it's good. I like this problem because these are the patterns you have to understand when someone asks you a problem to solve. They're not going to ask you to solve it by a stack or something. You guys have to figure out, okay, which data structure works for this kind of a problem.
Yeah. So we can go on to I think we did minimum stack. We're good to go to removing stars from a string. This one's, I think it's even easier than the valid parentheses, but all this is saying is you are given a string S which contains these stars like over here. And all we're saying is that in one operation, you can choose a star in S and remove the closest non-star character to its left, as well as remove the star itself. And it's asking to return the string after all stars have been removed. So if we see here, the reason we can use a stack is imagine if we're iterating through this whole string here, we're adding all the alphabet characters. So imagine we're at leet, right? Then we encounter a star. What we're gonna do is we're not going to add the star to our stack. We're gonna instead, once we encounter a star, that means we have to remove the closest non-star character to its left. Using a stack, we can know we know the topmost character, right?
Yeah.
Since currently our stack is going to be something like elite, right? We're going to encounter this. Then what we do is we check the topmost of the stack and pop it because it says to remove it. And removing it is an O of one time, and all we can do is just remove the T. And we wouldn't have to add the star anyways, because it says remove the star itself. So now we're at Lee. Then we have another star here. We have another star. That means we have to remove the top of the stack again, which are essentially the same thing as removing the closest non-star character. So now it's just LE. And we wouldn't append a star either. Then when we go to COD, we're just gonna add those characters to the stack since they're just alphabets. We get to a star again. What do? We check we do stack.pop, which basically removes the most recent character we added or the left character. So then we would remove this. And then we would last add E. So then this is our final stack, and all we would do is just return the stack. So yeah, this one's pretty easy. All we can do is do for I in range len of SI. We're gonna say is we're gonna create our stack over here. And we're gonna say if S of I is not equal to first a star character, right? All we're gonna do is just append that to our string. However, else what we would do here is if we get to a star character, what we need to do is do just a simple stack dot pop. Because that just removes the character. And I think over here we can just return the stack. But let me check if I'm doing this correctly. So if we're not at S of I, if we're not at a star, we're just adding these characters, which I'm doing over here. And if there are stars, all we would do is pop the top character, which would be, in this case, it would be T. And it removes it from the stack. So yeah. There might be one error over here which says
I think you mean S, not SI. Length of S,
oh,
not length of SI.
that makes sense. Yeah, so you see here is it's saying that our stack looks like this right now, and it needs to look like this right now, right? We need to remove the commas and make it out of its brackets. So all we can do is we can use some Python magic, which is essentially just doing this. It's essentially saying use these as like a delimiters and just join the whole stack as a string, as like a list essentially. So doing this will give us the actual string. So all we did was just we joined it together, all the characters, and added the quotation marks. I'm not sure, is that the correct way of how this is used for?
I've
Yes.
never used it, but I was thinking like if we did not want to use that, we can't, is our only choice to like run through the stack, since if you pop the stack and append it to a string, that's going to be reverse order. So instead of popping, you have to like just run through the whole stack and append each value to a string. If we wanted to do the without the dot join.
Yeah, these days, I mean, these even the spread operator and these join operators, they are very popular. I mean, everyone uses, all languages have almost same thing.
Okay, that's good.
JavaScript has as well. So I mean, this is pretty normal these days. So you guys have seen the spread operator, right? The 3 dots.
Yeah.
Yeah, it's a similar.
I have not.
It's opposite of that, basically. So you're trying to implement using character by character?
Yeah, it'll be something like this, right? Plus.
Yeah.
Yeah, plus is equal to you could do. Yeah. Wrong answer.
Maybe string plus stack I, not stack I plus string.
Yeah, it's just like that.
Yeah, you could say string plus equal to string I.
Yeah, that also works.
Yeah,
Just since this is in the interest of avoiding
Yeah.
Python magic, I guess we can try to be like as explicit as possible. But yeah, that would work also.
Okay, thank you guys. That's great work.
Yeah. So then I think on Sunday we can do a couple of more. There's this kind of algorithm called a monotonic stack, where what it does is essentially you want your stack to be always ordered correctly. Like you always want it to be either decreasing or increasing. And that is we use a lot of patterns in LeetCode. So there are a couple of problems we can do for that.
Okay, yeah, these were all simple so far. Whatever you guys have done are simple. I think I like the implementation also. So I think if we can find a way to implement these data structures also, even in Python, it was simpler, but at least it clarifies lots of concept people have about what is top and what is push, and all those things are helpful.
Good question. Savan, did you look into any other solutions for this?
Or
For the star one? Can you do this like by keeping like counts and just iterating backwards?
it's like 2
I
pointers.
haven't solved the problem, but I'm just wondering.
There is a counting tag.
Yeah. I didn't go through it, but yeah, I'm just curious to see because I'm wondering if you just iterate over the string backwards from right to left, and you keep like a count of the stars, you keep a count of the letters.
Oh, okay.
Yeah, and then you just
Reverse
kind
it.
of, yeah, no, like as soon as like number of count of stars, number of count of letters is the same, get rid of all your stars, get rid of all the letters, and then just keep going, you know?
Yeah, so you don't even need a stack in that case.
Yeah, you don't need a stack, you just iterate through, and then you build your string as you go. So like if the number of stars is 0 and you come across a string, that means that it come across a letter, that means that like that letter isn't gonna be deleted. So you just add it to your string and then you just keep building it.
Yeah, I mean, this seems more efficient, Subhan. I mean, because you are not using another data structure, you are just dealing with existing.
Yeah. So it's
But it's still
Yeah.
O then, like.
Space
yeah.
complexity
I
would be
guess
O of 1, right?
space-wise,
yeah, space of complexity would be O of 1 then. Yeah.
Unless, I mean, you are doing new string, but I don't think return values
Yeah.
count, so it would still be O of 1.
An
Yeah,
array
no.
is a lot more space
But
than
you need a
one
string in a stack also, anyways, right? You are also generating a string afterwards.
Yes, that is also true.
Yeah, this may be more efficient, but yeah, but it's good for us to understand, and also at the same time, if the interviewer asks, that is, you can do better. I mean, it's certainly we should have something in our mind about this.
Yeah, for like easy problems like this, like if there's a better solution, like usually they're not too hard and like to understand.